We're looking at the January 2020 Regents exam in Algebra 1. So first question here, if f of x equals 2 times 3 to the x plus 1, what is f of 2? So we really just want to plug in what f of 2 is, meaning plug in what 2 is into the function. So the input is 2 in for x. So f of 2 represents 2 times 3 to the second plus 1. So I took out x, I just made it equal to 2. So from here, what I would do, just to make sure you don't mess up any part of it, it's multiple choice. You don't have to show any steps anyways. Just type it in. 2 times 3 squared plus 1 is 19. Done. That, of course, is correct because 2 times 3 squared is 2 times 9 plus 1, which is 18 plus 1, 19. There we go. Nice, easy question to get started with. One high school, one half the players are limited. Let's see. So 64 players originally. And what equation models the number of players left after 3 rounds? So if they're losing half of the people every time, they're keeping half. So they're starting with 100%, they're losing 50%, which is equal to 1 minus 0.5 every time. So we don't want any 0.3s. That would be losing. If you're losing 30%, this would be adding 30%. That doesn't make any sense. And also, it shouldn't be adding. Doesn't make any sense either. So it can't be 2. So there's our answer, choice 1. So for this one, I'm just going to solve this. It's like a two-step equation, just a two-step inequality. So I'm going to do a two-step. I'm going to not touch the x first. I'm going to get rid of the 2 by subtracting. And then divide by 7. Nice little two-step. X is greater than or equal to 8. So greater than 8, greater than 8, greater than 8, or equal to 8, obviously, equal to 8. 6 is not in there. Done. Which table is a function? So which one has all inputs going to only one output? So we don't want any repeating inputs. So this is a problem because 2 goes to 2 and it goes to 6. So you can't have that. Same thing happens here. So you can't have 3. And then same thing happens with 3 going 2 different places for 4. It's got to be choice 2. Each input only has one output. This one's kind of interesting. Multiple choice, I'm thinking, what do we do? I would just use a calculator again. Kind of nasty, actually. So if you go to the menu and do use our numerical solve, algebra, you could type this whole thing in if you are careful. I mean, you've got 3 hours in the Regents, so you should have plenty of time to type this in, I would hope. Just because it's kind of nasty, and you can guarantee you have the right answer if you just type it right. So 17 over 12, and make sure you do comma x if you're using an Inspire. That way you tell it what you're looking for. 6, done. To solve it without that, you could multiply both sides by 12. That would be kind of nice because that would make it 12x minus 36 over 4 plus 24 over 3 equals the 12's cancel there, just 17. So divide both part by 4 here. That would be 3x minus 9 plus 8 equals 17. So 3x minus 1 equals 17. So 3x is 18. So x is 6. So really not that bad to do by hand. But you've got a calculator. Why not use it? Which expression is equivalent to this? So I can already see off the bat, all of them have a 2 out front. So that tells me, looking at the choices here, to start with that, take a GCF of 2. So 2 times 9x squared minus 25. And then that's a square minus a square. So 2 times 3x plus 5. And then 3x minus 5, because in order to do difference of 2 squares, it's always the square root of each one with a plus and one with a minus. So a plus b, a minus b, which is why it's 3x and 3x, 5 and 5, and then 1 plus, 1 minus. And there's our answer, choice 3. Looking at number 7, we've got f of x, and then f of x plus k is represented as g. So if this is f of x plus k, it went down 2. So k must equal negative 2. I didn't even read the question yet, but hopefully that's the question. Boom, that is the question. Great. Done. So it goes down 2. Adding negative 2 makes it go down. Love it. All right, number 8 here. This is a classic sequencing problem. So it's looking at the shaded boxes. So shaded boxes, not just total boxes. How many shaded boxes will be in figure 35? So we've got to first figure out how many are in the first one. So just a little bit of counting here. I see 2, 4, 6, 8, plus 4 would be 12. This one is adding 4 more onto it from the original, so that would be 16. This one would be 20. So if you're using the formula on the reference sheet, it's a of n equals the first term plus n minus 1 times d, which would be the first term, which is 12, plus n minus 1 times the common difference, which is 4. Or if you want to use, y-intercept and slope, the 0th figure would be 8 if you work the pattern backwards. So y equals 8 plus 4x would also work, because that would be a simplified form. It wants figure 35, so either way you do it, either 12 plus 35 minus 1 times 4, that will do it just fine. We know that's 34 times 4, which is 148. Or you could say, well, let's do 8 plus 4 times 35. That should also work. So either way you do it, putting 35 in for n or in for x. Just be careful if you're going to use y equals b plus mx or mx plus b, you use the y-intercept, which is the 0th term, not the first term. Most common mistake there is using the wrong number for the y-intercept. For number 9, this is a cubic function, but we're going to use what we know about quadratics in order to solve it. I know right off the bat it's going to have 0 as one of the roots, one of the zeros, because if you look at this function, there's a GCF of x squared. So it'd be x squared and then x minus 9. So 0 would work right here to make it equal to 0. So it can't be the ones without 0. So choice 1 is gone. And then if this can equal 0, use our 0 product property here. X squared equals 0 gives you 0. And then x minus 9 equals 0 gives you 9. So our options here are 0 and 9, and that's the answer. Nice two-way table here in number 10. Of the students spent more time playing games on their tablets. Ooh, that's a long statement that we need. Out of all the students who spent more time playing on their tablets. So let's see, approximately what percent were boys? Actually, this is everybody. Most time playing games. Oh no, this is videos on their tablets. Okay, so games. So playing games. So out of that total. So that's, I had to read it a couple times there. Sometimes it takes me a second. So out of those who spend more time playing games. So that's our total we want. Out of 192, what percent were boys? So that's our numerator. Out of 192, how many were boys? That makes the fraction. And then we just want that as a percent. So 138 divided by 192, control equals about 72% done. There we go. Just be careful how you read that one. Which statement describes the solutions of a two-variable equation? So two-variable equation. So let's think. So two-variable equation. It's kind of general. So that's just like y equals, it's two variables. It could be all sorts of things. Could be a line. Could be y equals, mx plus b plus mx. Could be quadratic. Those are two variables too. Let's see what makes sense. So the solutions, are they on the graph equation? Yeah. The ordered pairs must lie on the graph equation. That's it. So they don't lie near it. They don't have x equals 0, and they don't have y equals 0. It's just kind of a hard worded question, but actually a really easy one. A solution to any graphed two-variable equation would be on the graph. If it's a quadratic, if it's a line, if it's exponential, it doesn't matter. It's going to be on that graph. That's just kind of an interesting worded question. This one looks nice. This is just asking us to factor, as you can tell from the options, because they're all in factored form. So let's do x squared minus 10x plus 24. We're looking for two numbers that multiply to 24 and add to negative 10. So think about your factors of 24. They got to both be both be negative in order to multiply to a positive and add to a negative. So I'm thinking here like 1 and 24, 2 and 12. 2 and 12 you might think would work, but they got to both be negative in order to multiply to a positive. So that's not going to work. Negative 3 and negative 8 wouldn't add to negative 10, so that's out. Negative 4 and negative 6, though, that'll work. So it's x minus 6, x minus 4, and that's our answer. And that's the first 12 questions of this test.